Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today we're exploring a hidden force behind modern military power, not missiles or stealth jets, but the metals and materials they're built from. As warfare enters a new era of hypersonic speed, space-based systems, and AI-powered weapons, traditional materials just don't cut it anymore. The defense world is now racing to engineer lighter, stronger, and smarter materials that can survive extreme heat, handle crushing forces, and even adapt on the fly. The global market for advanced military metals and materials is booming. Worth $8.68 billion in 2024, it's expected to grow to over $11 billion by 2032. But this growth isn't just economic, it's strategic. Countries like the US, China, and India are investing billions in the material science race, pushing for an edge in the air, sea, and space. Take titanium, for example. It's been essential to military aviation for decades, prized for its unbeatable strength-to-weight ratio and resistance to heat. In fighter jets like the F-22 Raptor, titanium makes up over 40% of the airframe. And China's ramping up fast. It now uses more than 3 tons of titanium per aircraft in its latest fighters. But titanium is just the beginning. Nickel-based superalloys are revolutionizing jet engines, enabling them to operate at temperatures that would melt most metals. These superalloys power the F-35's engine and are critical for next-generation fighters and hypersonic platforms. The demand is so high, the military superalloy market is projected to grow at over 35% annually. Then there are metal matrix composites, materials that combine metals like aluminum with ceramic or carbon reinforcements. They're lighter than steel but tough enough for vehicle armor and radar systems. And high-entropy alloys, a newer breakthrough, mix 5 or more metals to create materials that can survive incredible heat and stress. These are being tested in railguns, hypersonic skins, and armor-piercing munitions. Even the materials themselves are becoming smarter. Some can shift their infrared signatures for stealth, others absorb radar waves. Graphene composites are making armor stronger and lighter, while self-healing alloys could one day repair themselves in combat. All of this is made possible thanks to major shifts in defense manufacturing. Additive manufacturing, or 3D printing, is now producing certified engine parts and precision components. Jeep, for example, has over 300 flight-ready parts made with 3D printing, cutting lead times by 75%. AI is also being used to discover and test new alloys in record time. But innovation doesn't stop at design, it extends to sustainability. Militaries are starting to reclaim metals like aluminum and titanium from manufacturing scrap, keeping costs down and reducing waste. Recycled titanium can now match 98% of virgin-grade performance at nearly half the cost. Regionally, Asia-Pacific is leading the charge with 45% of the global market, driven by China, India, and Japan. North America follows, with heavy investments in 6th-generation fighters and hypersonic weapons. Europe is innovating through joint programs like the Tempest fighter, while the Middle East is focused on drones and precision-guided systems. Of course, there are challenges. Many advanced materials are expensive and difficult to certify. Supply chains for rare metals like cobalt and aerospace-grade titanium are still fragile, especially with geopolitical tensions. But technologies like digital twins and recycled materials are starting to address those bottlenecks. In the end, the next wave of military superiority won't just come from new weapons, it will come from mastering the materials that make them possible. The battlefield of tomorrow is being shaped in today's labs and foundries. And in this high-stakes race, those who control the strategic metals frontier will define the future of defense.